Welcome to our podcast. We're here with a spontaneous special guest today with Gilad Feldman, and I'm gonna quote you from your own website to introduce you. He's an academic researcher in the area of decision making, social psychology, and behavioral economics, aiming for doing more good and doing better, engaging in open, meta, large team science, endorsing and promoting credible, transparent, and collaborative science. And you're an assistant professor at the University of Innsbruck. So, did I get all the important details, or am I missing something that we should
Yeah,
talk about
that's
beforehand?
it's a textbook introduction, but I think what it doesn't capture is that I'm very new in Austria. So I just joined the University of Innsbruck 2 months ago. It's my first time in Salzburg. So everything to me is very exciting. I'm going around Austria right now, first Salzburg and then Vienna, to meet people and to get to know what the different researchers and the students are doing and discuss all kinds of topics like open science, meta research. So I'm excited to talk to you about that.
So that's exactly why you're in Salzburg, right? And you gave a talk yesterday at our university for the Psy Talk series of our department. You were invited by Lukas Thümme to talk about large team collaborations, open science, and meta research for boosting research and impact, right?
Yes, yes. I was trying to give you a little bit of the journey that I had from when I was a student and why I joined academia, and then some of the discoveries that I've had along the way and how it brought me to where I am right now. So there were a few points in my academic journey where I realized things are not exactly as I thought they're going to be when I signed up to do a PhD. And throughout that journey, I took the initiative in order to try and understand where are we as a science, what is it that we can do in order to improve science, and what can we do as a community, including students as early as second year undergraduate, in order to try and boost things and make things more credible and more transparent.
So I'm gonna replay a bit and then come back to what you just said. But starting with a number in 2015, the Open Science Collaboration posted an article in Science estimating the reproducibility of psychological science. And as you mentioned in your talk yesterday, only 46 to around 49% directly replicated statistically significant results. So I think we all know by now there's a problem in psychology, right? The replication crisis. And now, an easy question, difficult to answer probably. What is open science? Maybe limited to the scope of open science in the context of teaching and relevancy for students.
Yeah, so I think some of the things both worry me and excite me, and I'm proud of them. So at the beginning, when we found out in 2015 that things are not as replicable as we expected, so people have different expectations. Some people had very high expectations. Some people had a little bit lower expectations, 50, 60%. I think to a lot of people, this science paper in 2015 came as a shock. And I think many of the first reactions were a little bit along the kind of saying that, so this is a psychology problem and we didn't expect much from psychology. So when you were talking to people outside of psychology, they would say, of course, psychology doesn't replicate. We didn't have very high expectations of psychology. Therefore, we don't need to worry about science overall because this is just psychology. But I think what's interesting about this whole thing and how everything turned out is that psychology was actually the first to look at itself and to do a replication project. One of the amazing things that I cannot comprehend um, is that we just don't do any replications. So you would think that continuously and all the time you would have a lot of replications happening all the time, but it took this mass collaboration for the first time in psychology published in Science in order to bring people together to notice something that's very fundamental to science, which is replicability. How many of the findings replicate? So back then, we weren't sure. Is this accurate? would this lack of replicability replicate again if we ran this again? What are the issues? What's causing this? Perhaps we did this wrong. Maybe we should try this again. And not just in psychology, but we also need to try this in other domains. Perhaps the hard sciences, or perhaps other domains that are very important for us in our lives, like medicine, cancer biology came out later, is that if we try over there, perhaps things are going to be better. What we know now, more than 10 years later, is that if anything, psychology is doing better than others in terms of replicability. Um, the replication rates are still very low compared to my expectations. But just last month came out a very big paper, 4 different papers in Nature, but one of them is about replicability. And what they've shown is not just in psychology, but also in other disciplines in the social sciences, replicability is somewhere between 40 to 55, 60%. And that's disappointing. And this is before we talk about many other issues like reproducibility and robustness and hypothesis and theory. Um, so I think it just took a very long time for this to come into light. Now, lots of opportunities for students in all of this because I think it's mostly early career researchers that came together and said, we want to go into this. We want to understand this. Why did I come into this? I came into this. I wasn't part of the science paper in 2015, but as a student, I wanted to build on top of the foundations that I read in the books and that I heard from the professors. I was trying things again and again and failing. In the beginning, people were telling me, okay, of course, you fail because you're a student. You just need more
Yeah.
experience. If you'll get better at this, then you'll meet all of the amazing findings by the big scholars. But now we realize that even when big scholars try to replicate other big scholars, they fail. So it's not about us being students. It's about there's an inherent problem that we need to figure out in psychology and beyond. So for students, this is both scary and an opportunity. We came into a discipline thinking, okay, we can just implement whatever it is that we've been told before. But now we know that the foundations are a little bit more shaky. But in there lies an opportunity because that means that there's a lot more room for you to contribute and there's a lot more room for students to come in with new motivation and passion in order to try and address all sorts of inherent issues and to try and explore as much as they can in order to build the foundations again. So everything is up for grabs.
So as a researcher, it's really important that you need to be published. And one of the problems that comes also is the publication bias, which basically means that the journals prefer to publish something that is significant. If there's an effect, and don't like to publish something that's irrelevant, let's say, if we can say it this way. So as a student, one of the solutions could be the registered report. So how do you think would it be possible for profs and for the students while writing a thesis in 4 months or under a year, if you're doing your master, to still have the registered reports
It's kind of
included?
a tight timeline, right?
Yeah, so there's a lot to explain in there. You know, we use a lot of terms like p-value needs to be lower than 0.05. And what does it mean significant? Does the word significant implies that something is really significant in its impact and its value? And not necessarily so. So we have this statistical method that we apply where we use null hypothesis significance testing in order to see whether there's some kind of a signal that indicates that something that we found is unlikely, and therefore perhaps there is something there that deviates from the assumption that there is nothing there. So because we use this method quite a lot, when there's this p-value, elusive concept of p-value lower than 0.05, then this is kind of like a signal that we found something that we should disseminate, that we should tell the public about. But because of the statistical properties of this very elusive concept, there's a lot of problems in that. And it seems like because this became the way that you get published, if you get the p-value lower than 0.05, then people understand that this is the criteria, and people use this criteria in order to try and get their own work, regardless of reality, to show that there is something very important and that this is significant, both in the statistical sense and in terms of the impact and value. So over the years, this is what we emphasized, and this is how we got published, and this created tremendous pressure. It's very difficult for a student to compete with big scholars who have big teams and big labs, and they have their reputation. So when a high scholar, high reputation scholar submit something to a journal, and the editor knows their name, then they're very likely to think, okay, this guy knows what he's doing, therefore give them the benefit of the doubt that whatever it is that they said is significant really upholds, the highest standards. But when there's an unknown student that comes from, an unknown university, then maybe less so. So there's a lot of room for this kind of, what is your reputation and what is your prestige to come into play. And this is even before we look at the p-values and what is it that's in there. Now, the problem with p-values is that it creates all kinds of incentives that are problematic and that we need to address. So, um, for example, so if we don't publish anything that is not p-value than 0.05, then we hide a lot of the things that people find. So I mentioned before, as a student, I failed to replicate a lot of different findings. It could be also that it's not a replication, but I have this amazing idea and I tried something out. But just turns out that maybe this idea did not find any support, and therefore, but the world still needs to know about this. But the journals only publish things that are significant or show that there is support for that. So we have this huge problem of a file drawer where people don't submit anything that they have that didn't meet this criteria. If we submit this, let's say that we don't care about this file drawer and we say everything that we have we want to submit, then comes the point of publication bias where the journals just reject this. So this has been a problem for a very long time, and it's not really clear when I talk to my students about this. The students are a little bit puzzled by why is that? Why is this the case? Why do we care so much about this p-value? But it could be that many times when the p-value is not lower than 0.05, something is very important. So for example, if we have a vaccination for a pandemic, and we want to know whether something works or doesn't work. So it could be that we have 100 trials for this kind of vaccination, and just because of the randomness of the universe, 2 or 3 of these trials are significant. But then we have all these 96, 97, 98 that are not significant. But if we only publish the things that are significant, we think, oh my gosh, we have a vaccination that works. Therefore, let's try and implement this, but we don't see all the file drawer or the things that were rejected from the journals that show that actually this vaccination is not good. So in order to really understand reality, we need to see not just the things that so-called worked or showed significant, but we need to see the other things that didn't work out. So this is where this innovation called registered report came in. So for a very long time, also when I was doing my PhD back then in 2009 to 2014, I felt this pressure about finding something that is significant, and I didn't understand why this is the criteria to get published, because it could be that you just have a very good research question, and that what you're doing, if you're testing a new vaccination for a pandemic, then that's something very valuable, and you want to know all these things because we learn from that and we can improve from that. If we don't know what the other person did and what their failures are, then we might repeat these failures, or we might overlook some of the things that are in there. So in 2013, a person called Chris Chambers, who I have a lot of respect for, came in with this new innovation called registered report. And the registered report turns around this whole peer review process for journals. So the traditional peer review is you do your research, you have your results, you write everything up, and then you submit this to the journal. So the editor and the reviewers, they see your outcome, whether p-value is higher or lower than 0.05, whether you successfully replicate it or not.
Yeah.
And based on this, they make an evaluation. This is already a problem. One of the domains that I study is judgment and decision making, and I know that we have a lot of biases. As humans, it's very difficult for us to ignore the outcome. So there's something called outcome bias. So just because the outcome is a certain way, then we see this as an indication for the quality. Oh, somebody found p-value lower than 0.05, very good researcher. Didn't find lower than 0.05, very bad researcher. There's also hindsight bias. So people in advance, when they conduct the study, They have all kinds of expectations, but then when they see the result, they forget everything that they had expectations before, and they reinvent what it is that they thought before they saw the outcome. So hindsight bias, and in hindsight, everything seems less surprising. So of course you didn't replicate this because of that.
Yeah.
You're incompetent or whatever. So Chris Chambers really turned things around and say, no, we need two stages for the manuscript. The first one is we write what's called a pre-registration, and this is just a plan, a very good plan where we set everything up, all our hypotheses, the research question, hypothesis, and data analysis, the method, the way that we want to address this. And then we take this pre-registration, we put this on a public website, and after we put this on a public website with a timestamp, then we start the data collection. So this really shows us that this is the plan that we had before we embarked on the data collection. So there's supposedly no outcome bias, hindsight bias. Register Reports takes this one step further and says, we take the pre-registration and we submit this to the journal. And then the editor and the reviewers don't have the outcome bias and the hindsight bias. They just evaluate the plan for what it is in order to try and improve this plan. And then when everybody comes together and agrees that this is the best plan possible, then the editor issues something revolutionary called an in-principle acceptance. And this means that no matter what the outcome is, this will get published. And this is remarkable because that means no more publication bias. So even if the p-value is not lower than 0.05, or if this is a failed replication, it will still get published. So the problem that we had before with publication bias is less of a problem in this process. And then the second stage, what's called the stage 2, is only to ensure that people followed what was happening in the pre-registration in stage 1. And this is an amazing opportunity, not just for science, but also for us researchers. Because if before we talked about students having this immense pressure to compete with all the big minds in order to get this p-value to be lower than 0.05, now you just need to focus on having the best plan. And then you don't have to worry whether the outcome is, turnout, not turnout. A lot of things, a lot of pressures just suddenly disappear. Another thing is that when you have an in-principle acceptance, then you can do things with this in-principle acceptance. For example, as a student, you can also put this on your CV and say, I have a guaranteed publication. It doesn't matter what I will find in my data collection. Now I know that it's going to get published. And then let's say that you don't have any resources because as a student, you rely on your mentor, your advisor, you rely on the university. Now you can go on Twitter X, Blue Sky, LinkedIn and say, hey, I'm a student, but look at this. I have an in-principle acceptance from a journal to this amazing plan that I have. Who wants to join me? Or another thing that you can do is you can go to a funder and say, you don't have to place any risks, don't have to gamble on me. You can just see that this is going to get published at the end. Give me the funding. So this is where I used this kind of method in order to convince my previous university, the University of Hong Kong, where I was before Austria, in order to fund undergraduate thesis and undergraduate projects. So before that, nobody wanted to fund undergraduate students. Like, why would we fund this? They'll never get published. But now we reverse this project, the whole process of how we work with students. We work on a pre-registration. They submit this as a stage 1 register report. We get an in-principle acceptance, and then I go to the university and say, look at this, an undergraduate student received an in-principle acceptance, guaranteed publication. Now will you fund it? And the university says, yes. They gave us $1,000 per student in order to conduct the data collection. So a lot of good things for science, a lot of good things for authors, a lot of good things for early career researchers and students.
So what would you say? Is it going to happen at University of Innsbruck too?
I really hope so. I'm still trying to learn what's happening at University of Innsbruck. I did a little bit of a shift. At University of Hong Kong, I was in a psychology department, and now, even though I know nothing about finance and banking, I'm in a department of finance and banking. So there's a lot that I'm still trying to understand. But definitely in my own work, in what it is that I do with my collaborators, we're going to try and submit as many register reports as possible. There are also some new revolutionary platforms that I really believe in. For example, Peer Community In. It's it does peer review by the community, for the community on preprints. So it's not a traditional journal. And it has different themes. One of them is psychology, relatively new in the last year. It has registered reports. This is already very well established in the last 3-4 years. We submitted more than 30 with my students and with my collaborators. We submitted more than 30 to peer community and registered reports. And to me, this is very, very promising because it does things just right. Not only does it do registered reports, but it also takes away all this pressure about which journal am I going to get published in. So we have this system in most of the universities about a list of journals. Or at the very least, we have this impact factor that determines where is it that we need to publish in. What's nice about peer community and registered reports is that you just do good work. You put everything as a preprint. You get identified and open peer review on your preprint. And once the community endorses this, you can go with this endorsement to any one of the supportive journals. And if it's what's called a friendly journal, then they automatically publish this with no additional peer review. Or you can go to your choice of a journal and just say, just so you know, this was already peer reviewed by the community. You can go and check with a DOI all of the reviews to see that these are very high quality. If you want additional peer review, you can waste your resources and your reviewers to conduct another one. But most of the time, most of the journals will say, this is actually really good. Just pass this through one editor and then it gets published. So we've done this many, many times.
One question, it's not on the script, but it just popped into my head. Wouldn't it contribute also to maybe trends in psychology because you're reliant on other people giving a peer review to what you're writing, so their input is given to you? But wouldn't it mean that it might make some topics in psychology, as it has always been, a trend? And could it go in a wrong direction then?
You're talking about peer community in register reports? I think it actually democratizes all of the process because for the first time, we open up peer review. Right now, we don't really know who is reviewing all these papers that we submit. So aside from the editor, who keeps it to themselves, and the journal, who have this in their own systems, let's say we want to evaluate what happened. Let's take the example of a vaccination again. A vaccination is submitted to Nature and Science, and then somebody says either reject or accept. We just need to take their word for it. It's a trust system, right? And then, let's say the editor can set their own trends. Perhaps they did this correctly. Perhaps they did it because, they're good friends. They know each other. They met each other in conferences, maybe from the same universities. There are all kinds of conflicts of interest that we cannot even investigate because everything is closed. When you have a platform like Peer Community In, where everything is open, then that really means that everybody can evaluate this. Everybody can see what's going on over there. So you can track whether this peer review really improved the process of the manuscript or not. In addition, when you have something like a pandemic, sometimes peer review takes 2 years, 3 years, how many rounds we don't know. It takes a very long time, but while this is happening, some people who can benefit from this paper miss out on this. The nice thing about peer community and register reports is that you first put this as a preprint, and this is open for everybody to read and evaluate and build on. Then it goes through peer review, and while it's going through peer review, takes as long as it does, people can still access this. So not only the reviewers and the editors have access to this preprint, but us as a community. So I can also go and comment on peer community in if I don't agree with this. So actually, everybody has more access. Everybody has more transparency. Everything has more accountability. So in a way, this kind of takes away all of the barriers from before and allows us to evaluate whether there's really like trends or maybe there's something that's influencing this that we don't want. In the previous system or the traditional system, or what's 99.99% of the way that we do science, has a lot of these things going on, but we don't know because we have no way of evaluating it.
So this all sounds really interesting and really promising for the future, so we can avoid another replication crisis. But if you would write something new, how can we deal with classics that we can't reply because of moral or ethical considerations. Let's take, for example, little Albert, because it can't be, we can't replicate it again. So should we still considering taking it in our considering taking it in our research, or should we just leave it out?
Yeah, so I think it's a good question of what are the ethical considerations that we care about, and then what do we do in regards to all the stuff that's already in there. So I am in the area of social psychology. This is part of the things that I focus on, and one of the classes that I give is what is the credibility of the classic findings that we have. So little little Albert, or let's say the classic Stanford prison so-called experiment, or Milgram experiment, and all of that. Do these things replicate? Are these things ethical? How was this conducted? What do we know about these things? And when you dig up the archives and when you learn more about these experiments, then you realize that there's some shady things in there that we need to correct. And then some people come up with all sorts of interesting ways in order to at least look at some parts of what is done over there. So, for example, Milgram experiment, which we already know is a little bit like there's all sorts of barriers over there in terms of morality and ethicality of how far we can do this. Actually, we now see in the literature quite a few replications of this effect, attempts for replication. And unfortunately, Milgram experiment, as much as it says all kinds of things about us and humanity, actually replicates very well. So now we've seen in different places throughout the time that the rates that they see when they do those replications are very close to Milgram. Stanford experiment is a different topic because there's all sorts of things that happen over there that now we know that make this to not be an experiment, and it was more of kind of like a show. So one of the nice things about replications and reproductions is that when we try to replicate something, we get to first think about what did we do back then? Was it okay, not okay? Can we do this better? Can we improve on the ethicality in order to study this better? And then, do these things replicate or not? So we all grew up, if you take any psychology, introduction to psychology course, all of these major findings are in there, but now we can look at them critically, we can evaluate whether this holds or not, and then we can think about what we can do moving on. I'm of the opinion that we need to be very transparent about our past, even if it doesn't hold very well. So yesterday I gave the example in the talk about there's this paper, Feeding the Future in 2011, where it's very obvious that even though this was published in one of the top journals, Journal of Personality in Social Psychology, there is absolutely no way that this finding is true. It's an impossible finding, but it's published. Many people say you have to make it disappear from the literature. You can retract it, you can do all sorts of things to it. But I think it is important as a record of back then at the time. It served a certain purpose, and then we can go back to it, we can reflect on it, we can do all sorts of things in relation to it. But we do need to change the books, and we need to revisit the way that we talk about things to be a lot more careful, a lot more humble when we talk to our students, or we talk to practitioners, or give a TED talk, or publish a book. We just need to make things a lot more cautious, saying, okay, so we ran on 20 participants back in Stanford, this kind of a show, and this is what we found. Before we say anything about that, before we write the books or do the TED Talks, let's do this again and again. Try to replicate this again and again within the moral, ethical constraints of what is possible. So replication just has to be inherent, and caution and humility need to be inside everything that we do. Only after we have an aggregation of an entire literature of a lot of different people doing high quality, open, transparent science, hopefully using register reports if this is a quantitative confirmatory study. If we have all of that, then we can do a meta-analysis, and then we can say, okay, now we know this. Right now, this is the best that we know. And now, based on this, practitioners, students, you can build on this in order to do something with this. But I think many times, especially in the realm of social psychology, we have this amazing finding. We found something one time with a sample of 20 in some Ivy League university, and then we go and write the book or do the TED Talk, but we need to take things a lot slower and work as a community involving many people around the world. And then we go to practitioners, then we go to the field, then we talk about what is it that we think that we know at that time.
Yeah. Also because psychology is, I think, known for being a kind of a flashy science, interesting findings, but sometimes it's also the maybe boring stuff that should be done first.
Yeah, so I think we have a lot of pressure to produce these amazing findings, these counterintuitive findings. We need to kind of establish ourselves as very interesting researchers. But many times, the very high quality research is actually, I don't know about boring, but it's a lot more systematic and it needs to be a lot slower. At the end, to me, many of what is considered to be the boring findings are, to me, the most exciting. So I do a lot of replications. So people often come to me and they say, but what is it that you do? You don't do anything interesting. What is it you do? You just repeat whatever it is that other people have done. So you take their ideas and then you publish with their ideas something that you just ran this thing again, and we're not even sure that you're running this well. And for me, I just think that we found so many interesting things in almost each one of the replications that we conducted. So people think of this replication as something very mundane, but in every step of the way, we can understand something about the scientific process. We understand more about theory. So one of the things that we do in replication is that we need for the first time to make the theory explicit. Many times you read a paper, you ask yourself, wait, what was the research question? So as a replicator, you go and you ask yourself, what was the research question? And you get to define it and you get to understand, is it falsifiable? Can we do something? Does the theory match the hypothesis? Do the hypothesis match the methods? Do the methods match the results and the data analysis? So in each one of those, we find gaps. And gaps are actually very, very interesting because we realize that actually, wait, this theory is missing something. Wait, when they only measured this, they missed another measurement. When they ran only this kind of analysis, actually, they missed a much better analysis. So this process of discovery through a replication process, to me, is very meaningful and very exciting. Plus, almost after every one of the replications, I come out with at least 10 different ideas of we have to follow up on this because we found so much potential for what it is that we can contribute to the field. So if anything, I think this is a lot more exciting because when you do things systematically, then you really understand the scope and the scale of how much impact you can have on the field rather than this one flashy finding.
Yeah. You kind of already answered like 5 of my follow-up questions, but one's still remaining. As a student, I'm still asking myself, okay, so now if I'm gonna write, let's say, my undergraduate thesis now, so what do I do? Like, I know the stuff from my lectures. I know I gotta look at the journal, maybe. I gotta look at the author. I gotta look at the citation, the impact factor, all the stuff we learned. But now what's missing? Like, oh, wait, but there's the replication crisis. So, what can I do? What websites might I look at? I know StatCheck, for example. But what would you say would be the steps, or what would your advice be?
Yeah, very good. And this is very confusing. And this is the kind of thing that I give workshops on. And these are the kinds of projects that I'm really interested in building tools in order to help people do better, in order to try and understand what is going on in the literature. So we didn't have good tools back then when I was doing a PhD. So it was very, very confusing. But with time, we create more and more tools in order to try and understand how solid is something that we read. But it is difficult because we don't have all of the tools. The tools are not perfect. And there's a lot of confusing signals and a lot of pressure from the system. So we do get this pressure that, focus on the flashy stuff. So when I was doing my PhD, there was social priming, which now we understand is a complete failure in replications. I was part of a lab, and something that was very trendy back then was ego depletion, willpower. It's in every book as the big promise of social psychology to the world. And now we know there's a lot of issues with how ego depletion is defined and whether this replicates or not. So how would we have known back then? Everything has thousands of citations, hundreds of articles by the best minds in the field. What can I say about all of that? But now we have some tools. So, for example, with social priming and ego depletion, if you put those into a meta-analysis, they will show you a very good finding. They will tell you this is a good effect, but meta-analysis now has an added feature called an adjustment for publication bias. So there are ways you can do a funnel plot, you can run a Eggers test or a Pete piece or a Robama or all of that in order to see are there some indications that there is a publication bias. Now we have also tools. So for example, a Shiny app called P-Checker, you can just upload all of the statistics from the different literatures, and then it will automatically create for you a nice meta-analysis summary with a publication bias adjustment with a funnel plot in order to give you some indication. Should you worry about this or not? So the first step with every student that comes to me to do a thesis is let's just run, take all of the statistics, check it with StatCheck, then see, plot all the p-values, see what the effect is and whether there's some indication for publication bias. In addition, not just with students, but also with practitioners. Practitioners are now very, very worried. It's like, can we trust anything that you bring to us? And I say, some things you can trust. How would you know? If there is some kind of replication, which is a mass collaboration, pre-registered, perhaps register reports, which is well powered. So you have a large sample, not the 20 participants from Princeton or Yale or Harvard, but cross-culturally from around the world, well powered. Um, and then it finds support for this kind of an effect, then you increase your confidence in that effect. If it has no replications, if it has no pre-registration, then I decrease that. Another indicator which is very, very important, did they ever share their materials, their data, and their code? So my confidence increases when I see all of those shared and when I download all of these and I run this, and I can see that I can get the same kind of results. So if I have meta-analysis with a publication bias adjustment, if I have a pre-registered or registered report for a replication, a mass collaboration, well-powered, then it gives me signals that something is more likely to be solid. Um, but we're still working on this, so we need more tools for that. So some of the things that I'm working on now that we have this power of the superpower of AI is that the AIs, if used carefully, can do very good work in scraping an entire literature, analyzing all of these things together to see all kinds of signals of problems on one side, but also for credibility on the other side. So the more powerful these things become, the more that we know how to leverage them, the more that we can check for all sorts of things. Some of the researchers, what's called the data sleuths, go over manuscripts in order to see whether the figures or the images have some kind of indications for fraud or for manipulation. But now we have a lot of these tools using AI or anything else in order to scrape the entire literature, look at all the images, and know whether these things, these signals exist in there. So I'm excited about these things because this is a very promising time for us to do all this meta science and open science to give you, the students, and to give practitioners, to give the field some kind of an indication of what is solid and what is not. Now, a lot more than 10 years ago, it seems like there's a promise of us overcoming all of these problems.
So I think we gotta write that down for later to remember. Thank you. Yeah, I think we're almost up with our time.
Yeah.
Yeah, but of course, like, do you have any famous last words, wise words for us, for all the psychology students in Salzburg, maybe you'd like to share?
Yes, I think a lot of students um, sometimes feel like they don't have a voice or that they cannot contribute because how can I know as much as the full professor or the journal editor or but I think if we've shown anything with this team that I run and all my projects with students is that students can contribute a lot. Students can find all kinds of issues with articles. Students can run replications. They can run reproductions. They can do high level, high quality research, just as good and sometimes a lot better than many of the senior scholars. Senior scholars, me included, have a lot of biases. We've been brainwashed with science that just does not work well. But the students come as a blank slate. So you haven't been brainwashed. You have a lot of good questions and things that you're wondering about. So my message to you is don't be shy about those questions. Ask those. If you get weird answers, don't just take it for granted, oh, the big professor said this, but go and investigate. It could very well be that you find something that we are wrong about. Many of the things that I do with my students, I am wrong about. And the students are much better than me. They're better with technology, with coding, and also at asking questions. So I learn a lot from my students. The only thing that I ask of my students is don't take everything that I say as a word of
Word
complete
from above.
truth. Yeah,
Yeah.
but I think come voice your opinion, ask questions, try and contribute as much as possible, and then together perhaps we have a chance of fixing everything that's broken and making science better.
Hopefully.
Working together as a team.
Yeah.
Right.
Thank
Great.
you.
Thank you so much for your time.
Thanks for
We
having me.
appreciate it very much. And I hope you still have a nice day in Salzburg. Maybe some nice sunny days still.
Yes, it's
Thank
lovely
you.
here. Thank you.